Okay, schematic diagrams. Okay, so let's go into these a little bit. This is good for you to take a picture of and keep with you at all times. These are a lot of the symbols that you're going to go through and see while you're out in the field. Okay? So this right here is a non-connected wire. You see this on the deal? It goes over the wire and keeps moving on, right? These are connected, okay? So everybody keeps asking about the little red dots. That's your little red dots right there. They indicate a connection or a crossing in a wire that sheds power out further on.
They're not necessarily red.
No, they're not necessarily red. If you actually get the color codes in the schematics that they used to be red dots. They don't do that anymore. That's just the way it is, okay? Another one that you're going to really need to know is resistance, okay? Variable resistance, it's going to be with an arrow through it. That's like what you're going to see on some of these back here that have the VCCs. You'll see that. Variable capacitance, polarized capacitors, regular capacitors. These are all important, okay? Here's an inductor, voltage source, current source, okay? Chassis ground, earth ground, toggle switch. Straight line is just nothing more than an electric wire. Okay? So these are all very important to know. Your voltage source, just like with a battery or with a flashlight there where you got to put the batteries in, it's going to tell you which side's plus, which side's minus. Current source, it's going to have a little arrow in it. It's going to be pointing the fact that that power is going to go that way. Okay? A battery cell. There's two different types. So this is multiple battery. This is a single battery. And then a diode. You see how that arrow goes? That arrow is one direction. It only flows one way.
Yes.
So how when you're looking on a diode, can you tell which direction it flows?
Another way the arrows are.
It has a strap or a line on it. And it can be anywhere from 1 to 5 lines on it. Well, that'll tell you how that goes. It only goes one way. Motor, transformer. We've seen transformers in microwaves. Fuses, of course. Your load source and your neutral will be marked as L1 or L2. Neutral is always marked with an N. If it's a ground, it's always going to be marked with a G. Or with the signal signs that we saw a while ago, the bar with 3 other little lines under it. Okay, so we have this schematic here. Who can tell me what some of the symbols are? What's this?
Diode.
Oh, no, you're wrong. See the 2 little lines on the outside of it? That's a triac. We ain't gone over that yet, though. Figured I'd throw one in there at you that you didn't notice.
I thought the triac was the 2 triangles next to each other.
They can be, but there's also a different type here. There's the triac on the board, and then the triac that's separate. Because some triacs on the other ones can actually sit in the bottom of the microwave, on countertop microwaves, to split that signal back and forth.
What did triac do again?
They send power to one source or another as it needs to do what they want to do.
What about that top triangle when that has no line to it?
This one right up here, that's diode. Okay? Here's your motor down here. Okay? A little more complex, what is this?
That's what it is.
Huh? So what's right here?
Inductors.
Coils.
Inductors, or is that a transformer?
Oh,
Resistors?
okay.
So here's your plus and minus up here for your power sources. So this is operated by whatever your power source is coming in, right? It could be AC, could also be DC. Here's your ground over here. Here's your ground here.
Earth ground and.
Earth ground and chassis ground.
Board.
Okay? Reading schematics, here's some codes and stuff you need to be able to read schematics. Your name identifier and the components that they are. So we have our battery source, we have a resistor, and we have an LED. What does LED stand for? Light emitting diode. That means the path only goes one way through there, right? So a light emitting diode is still nothing more than a diode.
You got a triac? That triangle?
No, a that's not a triac, see the lines underneath? That means it's a diode, okay? So here's a junction in your wire again, here's a wire that goes over. So how to read a schematic? A lot of these are not connected, but if you look on your boards, all your Samsung boards will tell you what your volts are out, what your volts are in. What is this?
That's a capacitor.
That's a capacitor. These dots are connections. No dots here?
Not connected.
Not connected, right? What are these right here? So this one right here is a standalone capacitor. These are on the board capacitors. See how they got microfarads listed underneath them? So there's a little bit different symbol if it's actually attached to the control board as compared to one that's a standalone. Okay? What about over here? What do you have here? LEDs, diodes, okay? What about here?
Resistors.
Resistance. What about here?
Switches.
Switches.
No bells.
What type of switch? Two little triangles together, maybe what type of switch?
Triac?
A rocker.
No.
They can be a rocker or a triac switch, or they may be a relay. But sometimes the triangles will be one right beside the other, upside down, or sometimes they may be seen like this. But they also designate relays like this. Okay?
What's the X again?
Which X?
Next to R, X, LED? Is that relay?
That's a relayed LED, yeah. So what happens on that one, if you see here, that goes up that side, this goes up that side, but then again, it may be coming from a signal from another board to tell this what to do over here to make those energize. So this may be your control board over here, and this may be your main board. Okay? Recognize voltage nodes? So what do we have on here for voltage nodes? What is this? So this is your power in, right? Your power back out, so you got your 5 volts, your 3.3 volts. Same thing down here, but see how everything goes back to the ground? Okay? So when you're looking at a circuit board, everything goes back to a ground. Low voltage, DC voltage, can go back to a ground. And then it goes back to the main section of the board, and goes back to the neutral or the ground. That's why your ground is important, because most of your DC circuitry always goes back to a ground. So when you're testing your voltages on the fans on a refrigerator, you go from one pin to ground. You go from the next pin to ground and see what your voltage is to that fan. If you're doing the feedback, you still go from that next pin on your feedback to your ground. So if it's the connector CN30 on the refrigerator, you're going from 13 to 15 to get your primary voltage going to the fan is 7.62. Then you go from 13 to 17, and you get your feedback voltage, which is going to be anywhere from 2.3 to 2.7. That's extremely common for all of Samsung's products that has a DC circuitry for their fans. Or if it's on CN76, you're going to go from pin 1 to pin 3 for your fresh food fan, but then you're going to go from pin 1 to pin 7 for your feedback. Okay? You really need to know this stuff like I do. You'll get it down when you go over it a lot of times. You keep doing it. It'll become second nature to you. You go in and say, oh, that's CN76, I need here and here. You get that familiar with what you're doing with more time, okay? Because most of the things on that refrigerator back there, those refrigerators back there, I can go back there and test and never look at a schematic. I've done it so many times. Becomes second nature. And the more and more you do it, the more and more you troubleshoot from the board, the more and more you work through your circuitry, the more knowledge you're going to gain, the quicker you're going to troubleshoot, the faster you're going to find your problem, and the faster you're going to solve the customer's issue.
So, before you leave, so the LOB 358, those are net names.
Do what? Yeah, they're net names.
Okay.
Okay? Two different types of circuits. Of course, we got the series and the parallel. Okay? So there's series, there's parallel. You got your battery. You got resistors. Okay? Over here we got lights in place, whether they be LED or whatever. Simple diagram. Your power source, your LED, your switch. So battery, switch, diode. 1, 2, 3. Just like that. There's your battery, switch, and your LED, your diode.
And actually, what's the little arrow here, guys? I mean, here,
That shows you the path of the flow is going. So the path is coming this way and going out.
That should be pointing up that way.
It does, but it's still giving you an indication which way that power flows.
It lets off light.
The LED lets off the light, yes.
Isn't that what the arrow means? It's a light activity.
Yeah, that's also giving you a direction of the path. So it's coming from the plus side of the battery through the diode to the switch. To complete that, they've got to close the negative side of that switch so that it gets full path. Yep. Okay, this is a basic refrigerator diagram. Okay. You see where the interior light is here, the door switch is? Thermostat, what would this be?
On the evaporator?
That on the evaporator?
No,
That's your, that usually is found in the top mount. What is that called?
your ice cream, or freezer,
No, this is usually found on a top mount refrigerator.
on top of
It's usually right in the vent, right underneath, and you can actually control your defrost and everything. So it's called the defrost timer. It is a mechanical timer. Now there's 5 or 6 pins on a mechanical timer, and you can actually move the wires so that you can get 8, 10, or 12-hour defrost cycles. Okay? And it sets up that timer for that. Okay? What would this be?
It's the temperature sensor?
It's a thermal fuse,
It's a thermal fuse?
isn't it?
On this particular type of circuit, that's going to be called a bimetal. Who knows what a bimetal does?
Closes and opens based on temperature?
Closes and opens based on what it needs for temperature, right? So that defrost timer goes in, it actually sends power to this, it's going to close. It's going to send the power to the heater, allowing the heater to come on until that timer times out and says, I'm defrosted. Then that's going to open, and that's going to cut the circuit, it's going to cut the power to the defroster.
Would that be the same as a thermal?
No, it's not the same as a thermal fuse, it is a bimetal. It is a little different than a thermal fuse. Okay? Like for Samsung, door openings, the amount of time the refrigerator and everything's been running, all this stuff goes into it. And then that sensor in there that's actually attached to the evaporator, which is a temp sensor or a thermal fuse, okay, is going to tell the heater to come on. What the bimetal in those do, it's actually another temp sensor with a resistor in there. All it's going to tell it to do is send a signal back to the board to tell it I'm done defrosting. It doesn't open and cut the power. That's all done by the circuitry in the board. So that makes it operate just a little bit differently.
I have a question. Is
Yeah.
that similar to the one on the oven, the hot indicator light?
Kinda, yeah. Not exactly, but pretty close. Okay, so, but when the timer's in normal position like this, it's running the power down to the compressor. Okay? Telling it to do what all it needs to do. So that's just a real basic diagram for a refrigerator. So you got your electrical load right there. How your load flows through the defrost timer switch to your compressor. Did everybody get a picture of that? Sorry.
Thank you. Thank you.
Okay, so here's some more examples. Some of your refrigerators and freezers will have a diagram right on the back of them. But on this model serial number tag, you're gonna find more information than just your model number. You're gonna find how your circuitry, basic circuitry works. And then you're gonna come over here and you're gonna see what type of refrigerator you have, how much your charge is, what your storage volume is, what your gross volume is. All that can be found on this tag. That's all the information you need to know about that refrigerator. And this happens to be what type of refrigerator? Using 50 hertz, 230 to 240 volts. This is one that you're gonna find from Sharp. It's gonna be a European market one. Okay? Your start relay, your door switch, your defrost thermistor, all that's going to be all in your circuitry. There's your thermostat, your interior light, door switch.
So that's the answer to that question of what we see before the compressor.
Yep.
The relay doing switch defrost thermostat.
Yep.
Thank you.
So if the compressor was not engaged, but you tested to ensure that the refrigerators were receiving power, then you would test what next? I would check that timer, make sure it's not in a defrost cycle. I would check the door switch. I would check my power source. What else would you check?
Thermostat.
I would check my overload here. Okay? And yes, the thermostat would be one of the things that you'd want to check. You'd also want to check and see if the fan's working. But just a real quick test, right here, right there, and right there would be the three things I would check first if that compressor's not working, because if that's not sending power to it, it's not going to work. If that overload is tripped, it's not going to work. If you don't have the proper power, it's not going to work.
You jump that really?
What, the overload?
You know,
You can, but it's not advised. But there are jumper kits out there to stick on those to see if the compressor comes on. Okay? Major appliance schematics, so let's go through a little bit of multimeter stuff. You'll use this on every appliance, not almost every job, you will use this on every job. Let me reiterate that. Not almost.